Okay, so first we are going to be doing an executable payload. This consists of multiple steps. We are only going to get so far in this particular lesson as to create the payload, send the payload, set up the listener, and then establish a Meterpreter session, and I will do a few post-exploitation tasks. I am not going to do persistence because I'm going to save that for Friday, and that is going to be done using the service executable, because the service executable is still something that will be a feasible method of getting persistence, because it's something that you can restart every time the Windows system boots, and it may not get picked up by antivirus. But if you use the built-in persistence modules in Metasploit, that will get picked up by Windows 10 if antivirus is turned on. So the first thing we're going to do, just in order to make things a little easier for us, when you are creating a payload, we'll go ahead and open a terminal. We'll probably be opening a few more on top of this, but we are going to be sending this over using a command line. There are some cheats if you're going to be doing this on locally using VMware. If you have VMware tools installed, you can drag and drop. But since we are going to be doing this eventually on the Cypher network, you cannot drag and drop from one environment to the other. So it's better that you learn how to transfer things manually, since that's the way you'd be doing this as an attacker anyway. So one method that Kali Linux lets you do this is it has a couple of different kinds of ad hoc web hosting services, one of those being Apache 2. So in order to access and use Apache 2, we go to File System, var www, and when we get to the HTML folder, we have to open this as root. Otherwise, we cannot move anything in or out or delete anything from this folder. So we right-click on it, open it as root, and then validate. So then we'll just set this to the side for right now, but we also need to make sure that the web hosting services are running. We do that by typing systemctl start Apache 2. And then we have to validate again. So now we have our web hosting services that are running. So all we have to do is create our payload, and then we will be able to move it over here when we're done. So we will open up we'll open up two. Even though some of these things are probably already in memory here, I'm going to go through them just for the sake of explaining everything. One, we'd first, if you did not know already, you would need to get the IP address of your attack computer. And in this particular one, it is 192.168.245.129. It is important in this case. This is one problem that I had to keep addressing when we were first learning this. And that is, you need to make sure that you have awareness of the IP addressing that you have in your environment. Because if you are not in the same subnet, you are not going to be able to scan anything. You're not going to be able to send a payload over to another computer. You're not going to be able to establish your reverse TCP connection. So remember, the first thing you do just to check is going to be check your IP address. So in this case, 192.168.245.129. This is our subnet, 245. Then I'm going to go over to the Windows computer. We know that in Windows, checking the IP address, you type in ipconfig. Let's see, 169. Let me make sure that's correct. That's 245. Oh, that's one. All right, so we see this is not in the right So I need to make sure and check the virtual machine settings. And you can see right away that this is not going to work. I have to restart this because this was in the wrong network adapter. This is another good thing to check, because if a network setting is incorrect, that's going to mean you are not going to be in the same subnet. So in this case, I'm going to have to change the network adapter so that we are in the same subnet. So in this, we have to change to NAT. I believe I'm going to have to restart the computer too. And while that's restarting, I will go back to our Kali Linux machine. So it is always good when you are doing this to make sure that all of your administrative housekeeping has been checked and validated. And that would be things like your web hosting services. Are they running? Check your IP addresses. Are they in the right network adapter? Are you in the right subnet? So when all these things are it's attention to detail. So when you do this enough, it is not necessarily that difficult. It is just a lot of steps, and it's a lot of attention to detail, because things have to run correctly in sequence, otherwise it will not work. So once all of this is done, we are going to create our payload, and we do that using the Msfvenom command. And I will go through each of these. We're not doing an exe service. We're going to be just doing a plain exe. And I will just call this implant. So first off, we have the Msfvenom command. The -p tells us that this is a payload that we're going to pass it. And our specific payload that we chose is going to be a Windows Meterpreter for a 64-bit architecture, and it's a reverse TCP connection. The fact that all these items in this specification, in this parameter, are separated by // means that this is a staged payload. There's a difference between a staged and a stageless payload. That can mean the difference sometimes when you are doing an attack, because antivirus sometimes will not pick it up if it is staged. But likewise, that's why you experiment with some of these things. But yes, that means the components in the payload are separate. Like if you write your own payload, you could do it in such a way to where you have a launcher, and then the actual payload itself will be off the computer on the internet somewhere. So part of it will execute, and then that script will pull down the actual payload, and that will work together. So all the components that form your payload will be separate items, but they will work together. Some of these, like when I created a payload over the summer using C++, everything is all in one document. The payload was shellcode that was in an array, a C++ array. In that case, everything is all together. It is stageless. So, but when you are looking at it from the view of Metasploit, the / mean that it is staged. So we have to have our lhost, and this is another important item, because lhost, you could call it localhost. That is the attacker machine. We want the connection to come back to us. So I've had other people make mistakes, and they will put the wrong IP address here. They'll put the victim's machine, which means you are going to be sending the connection back to yourself. So you want to make sure that the lhost is your Kali Linux machine. And then the lport is going to be the port number that you choose. So, and it's also advisable to not use a lower number for ports, because a lot of the lower level port numbers are already occupied by other running services, and they are also usually what are scanned by default by programs such as Nmap. So it's better that you pick a port number that is higher. But some scanners are also programmed to look for repeating numbers, because when we pick port numbers to help us remember stuff, we sometimes pick things like 7777, so we don't have to remember several different numbers. We're doing that because in this exercise we're not really looking to avoid antivirus. But in this, you could pick something like 1234, 8888. But if you are really hoping to avoid detection, you would pick something higher that had a variety of numbers in it, so it would at least not stand out so much. Now, I'll actually pick another. I'll make this 2345. I'm going to go back to my Windows PC here and check. And I will check the IP address on here again just to make sure we are in the correct subnet, so we can actually send our payload over and have a successful connection. Come on. See, now we are in the right subnet. We have that 245. So it's a good thing I checked this, but that is something that you should make sure to check when you are setting up your attack. Just like if you were actually going to be doing an attack on a target network somewhere else, you would want to have a very thorough initial scanning and information gathering, because you want to make sure that what you've got is going to be able to work with the environment that you're going into. So now we know that we are in the right subnet. Oops. And we have our ad hoc Apache 2 web server set up and the service is running. So now, and we have our Msfvenom code, which is going to send out our file to the desktop. And we didn't get any errors, so we know that the thing finished successfully. So, and it is right here, we see implant.exe. And now that we have actually opened up the HTML folder as root, I can just drag and drop my implant.exe file in there, and now we are ready to transfer. And just another piece of housekeeping, I am going to go ahead and start the listener. So that's one extra thing I do not have to worry about when I transfer my payload over. So I will open up another terminal. This is another thing that I'm just saying as a suggestion. When we were first learning this, a number of people would run everything out of the same Linux terminal window. That is not advisable. For one reason, you want to keep some of this information sort of compartmentalized. Like when I'm writing creating my listener, I want to be able to refer back to what I have in my payload. So I will leave my Msfvenom statement window somewhere to the side so I can get back to it later. Likewise, you want to leave some of these other things separate in case you have to refer back to them later and they don't get confused because they're all stuck in one terminal. So to start our listener, we are going to use the multi-handler, and that is in MSF console. And after your ASCII artwork appears and you have your MSF6 prompt, we will type in use exploit multi-handler. Then you'll know you're in the multi-handler when the prompt changes to a red inside the parentheses. And we want to create our listener in such a way where it will accept our reverse TCP connection. And to do this, we have to give it 3 pieces of information that are accurate, so it will know exactly what type of connection to wait for and receive. Because if any of these are wrong, you are going to either get an error or it's just going to sit there and do nothing. So it's important to make sure that these 3 parameters are correct. And that's why I leave my Msfvenom window separate. So the first thing we're going to put in is our payload. So you can actually just copy it by highlighting it, doing copy selection, and we will type set payload. Let's see, paste selection. And you will receive a validation printout saying that it now knows that it is waiting, it is expecting a 64-bit Windows reverse TCP Meterpreter. Second, we have to give it the lhost. Set lhost, and this is why we do our if config. So now we're going to put in the Kali Linux IP address. Oops. So remember, now it knows it is going to be expecting that particular kind of reverse TCP Meterpreter, and it's going to send the signal back to that IP address, which is our attacker machine. The last piece of information it needs is going to be the port. So we send set L port, and we used 2345. So now that it has all 3 of these pieces of information, we can just type in exploit. So now, when it says started reverse TCP handler, it's going to be sitting, it is now in its passive waiting state. So now that everything else is ready, we can go over to our Windows machine. And we have a few pieces of housekeeping to go over here. First of all, for this, we have to shut off our security. Because I may throw out a challenge later where I'm going to see if you can get past Windows Defender. But for these exercises, what we're doing has long since been patched by antivirus people. So whatever we're doing is going to get picked up by Windows Defender. So for this exercise, we have to turn it off. In order to do that, you type in security to get the security application up. We go to this on the left, this little shield, the virus and threat protection. And we go to virus and threat protection settings, manage settings. And then real-time protection, we want to turn off. But then also leave this application open, because for 2 reasons. We are going to be whitelisting a folder, and we do that from this same app. Another reason is if you turn off antivirus on Windows 10 or later, and you leave it idle for a period of time, I don't know the specific amount, it will turn itself back on. So it's best just to leave it open so you can go back and check it again later. If you had to leave, if you had to make a bunch of changes and you come back, you can bring this up and check to make sure that this thing is still turned off. So next, we want to create a folder where we are going to be sending our payload when we transfer it over directly. We can do that. So directly on the C drive, we'll just create a new folder, and we'll just call it Tools. On Friday, I am going to show you how to do some of these things from the Meterpreter session. We're going to start off with a Meterpreter session, and then we will get it down to a PowerShell session, and we will be able to create folders, whitelist them, and do all of this stuff directly from the command line. But for right now, so we can actually get all of this stuff accomplished, we're going to just manually create it and then put it in the exclusions list. So we created a folder just directly on the C drive. We called it Tools. Now we are going to go back to, I have to go back one, or is it still under Manage? Exclusions. So we find this section called Exclusions, and we go to Add or Remove Exclusions. We go to Add an Exclusion, and we're adding a folder. We're going to add the Tools folder. Now that it shows up, this means that antivirus is not going, it's going to ignore this folder. So we're going to be transferring over a payload, which is seen automatically by antivirus as malicious. So, but the reason why we turn off antivirus as well is because even though it's not going to zap the file itself, if you run this payload, then if it's not turned off, it's going to kill your file and delete it. It won't run. So in order to actually execute the reverse TCP, you have to have Windows Defender turned off. So for right now, we have our whitelisted folder. So now we have to use the command line, and we are going to go into that folder that we just whitelisted. I'm going to see if I can make this any bigger. Okay, so this is another thing that you just need to be able to work with. Command line navigation. So we are directly in the root of the C drive with our tools folder. And we are currently, when we bring up our command prompt, we are in the user's student directory. So we have to go up 2 levels. To do that, we do cd ... Let me do that one more time. We can do a dir to see what's in this folder. And there's our tools folder that has been whitelisted. So we want to go inside that. If you want to clear the screen, you have a lot of junk, CLS. So now we want to transfer our payload from our attacker machine, where it is being hosted by Apache 2, over onto our victim machine. So we are going to use, there's a number of things you could use. The one I showed last semester, and I'll use now, is called the curl or CURL command. To do that, you need CURL, and we need to get the IP address of the attacker machine, which is so it needs, CURL needs a fully formed URL. In this case, we are using our Kali Linux attacker machine as a host. So its URL is going to be http:// its IP address, one more / and then the name of the file that we created, which in our case was implant.exe. And this needs one more parameter, and that is the output. So we have specified the location and the file name that we're transferring. We also have to tell it what do we want this file to be called when it is moved over. So you have the -o for output. I'll just give it the same name, implant.exe. And you will get that output, and then if we go back to our tools folder, let's see. So now we have our transferred payload, which is now sitting inside of our victim machine in the tools folder. Now once again we will check, and it is still turned off, and we have our reverse handler running and it's still in the waiting state. So execute it as an administrator. See, this is one thing that you have to make sure to do as well, because if you do not execute it as an administrator, this, even if a Meterpreter session forms, it will, I believe that causes some problems if you're going to try and get escalate privileges later. So when you execute your payload, make sure you run it as administrator. So now we go back to and now we have a Meterpreter session. This is our reverse TCP Meterpreter session. So now we'll just check our current privileges. That is just a pedestrian user. We'll see if get system works. Oop. So now I have NT authority system. There's a number of ways that you can get your privileges elevated or escalated. The reason we want to do this is because a lot of the things that we need to do after we're on this machine require the NT authority system level privileges. You're not going to be able to do much with just that, desktop student privilege level. You might be able to just move around using change directory, but you're not going to be able to dump passwords. You're not going to be able to probably move laterally or do a host of other things. So get system is one way to do that, but that does not always work. What get system is a script written in Ruby, I believe, that has 5 different executables that are executed in tandem. They're all local privilege escalation executables. And if all those run in sequence and none of them work, you'll get an error message, and it'll show you all the executables it ran that failed. If that happens, you can do a process migration. We're going to be doing one of those now because I am going to demonstrate the keystroke logger. But if you're going to be escalating privileges using migration, you'd first have to enumerate your processes, the running processes. And you enumerate processes by typing PS. And you have a list of all the running processes. Whenever we pick the process we want, we have to look at this, or not this particular number, but the numbers in this farthest left column. So if you were going to try and escalate privileges, you would want to transfer to something like LSAS or something similar that has this NT authority level privileges, and then you would get the number. But one thing I did not do on the Windows machine that I'm going to do now is we need to have an object in which the victim can write into, so we can get that process number so we can migrate to it. So to do that, we're going to go back to our Windows machine, and we don't have Microsoft Word on here, so I'm just going to use Notepad. So now this will be, for example, if the user has opened up Excel, or they've opened up probably more than likely Word or something else, or even a browser. If you know from spying on them that they use Google Chrome, you would probably want to migrate into that Google Chrome browser, because then you could get all the websites they've gone to. You could probably get the passwords that they've typed into a number of websites. But for this example, we're just going to use Notepad. So Notepad has been opened. We're going to run, since we just opened that, we will re-enumerate. And now we have to find the Notepad process that's running. Let's see, there's LSAS. So if you're going to try and escalate privileges, you'd migrate to 832. There's Notepad. That's 1764. So let's remember that number. So migrate 1764. See, so we have successfully migrated our Meterpreter session over to process ID 1764, which is the Notepad instance. So every program that runs on Windows is assigned a PID or process ID number. That information will come in handy for later for several different kinds of hacking tools and techniques. So now that we are inside of the Notepad session, we will type keyscan start. So we will go back to our machine of our oblivious user, and we'll say, I am typing all kinds of personal and confidential information. I don't and then we type key. So we dump that, you type keyscan dump to actually just dump everything that's currently in the buffer. So you can see everything that I just typed. It will even give you the other keys that are involved there, like shift. So this is something that I'm going to incorporate into our scenario when we start the first part of our offensive mission. So once you have done your initial OSINT, once you have done your initial looking at information of your target, and you have actually gotten onto your target's machine, I will pose as the oblivious user that you're targeting, and then you will step out for a little bit while I enter this information, and then when you dump the keystrokes, that will give you some of the intelligence that you're going to need to actually move on to the next level. That next actual official network that you'll attack will be on the Cypher network. So I'm going to think if there's anything else just locally. I think there's, let's see, our screen share. If we type screen share, this is a sharing service, much like if you're using Zoom or Microsoft Teams, where you are oblivious to them. They don't, let me see if I can move this out of the way. So you can actually see what they're doing in real time. There's going to be a slight lag because the information is being transferred by this probably slightly slower speed reverse TCP connection, but since it's a screen share, you can actually see what the person is doing on their screen in real time. So that is, I don't think there's anything else that I'm going to be demonstrating on this one as far as post-exploitation. Because some of the other things I'm going to do when we are, actually, I'm going to go ahead and stop this lesson now, and I'll wrap up this particular session.